Hello everyone, welcome to this webinar. My name is Titus Kurek. I'm a product manager here at Canonical, and today I am super excited. I'm super excited because I'm in a room full of data science experts from both Canonical and NVIDIA side. So just looking around the room, we have Dave Montana here together with us. Dave is VP of Enterprise Sales here at Canonical. We have James Page. James is principal engineer in Canonical's OpenStack engineering team. And on the NVIDIA side, we have a number of our special guest speakers. So first of all, we have Judy Lee, senior product marketing manager, Michael Shen, principal product manager, and Charlie Huang, senior product marketing manager. So today, together, we're going to talk about open infrastructure for data science based on Canonical OpenStack and NVIDIA vGPU software. The NVIDIA vGPU software enables data scientists to break through the constraints of hardware scalability, making highly performant GPU resources available on demand for cloud users. And since more and more organizations are moving back to an on-prem infrastructure these days due to constantly growing public cloud costs, OpenStack with NVIDIA vGPU serves as a cost-effective alternative. Backed by joint commercial support from Canonical and NVIDIA, it is fully suitable for production environments with sophisticated AI/ML applications running on it 24/7. If you have any questions, feel free to raise them through the question box at any time. There will be a dedicated Q&A session at the end of this webinar, but you can put your questions in advance, like you don't necessarily have to wait until the end of the webinar. And if you raise your questions early, we'll be able to prioritize them. We are going to navigate through the following topics. We will start with an overview of the Canonical NVIDIA partnership and what we've been working on together for the last few months. Then Judy will walk us through the internals of the NVIDIA vGPU software and demonstrate how it's used in the data science field. Later, we will discuss the benefits of using the NVIDIA vGPU technology on the top of an Ubuntu-based infrastructure, including low infrastructure maintenance costs, low entry barriers, and Canonical's fully managed services. After that, Dave will walk us through some sample use cases for NVIDIA vGPU in business based on his rich experience in energy, automotive, and healthcare industries. And finally, as usual, we will take pride of demonstrating our solutions to the audience, and thus James will host a demo for us during which he will demonstrate how to enable and use NVIDIA vGPU technology on Canonical OpenStack using high-level abstraction and automation provided by OpenStack Charms. And finally, we'll summarize the webinar with some key takeaways and open an interactive Q&A session. Before we dive into technical details, let's stop for a moment and zoom out to see what Canonical and NVIDIA are working on and how their products fit together, enabling data scientists to implement an open source, cost-effective infrastructure. So if you think about that, when it comes to data science stack implementation, you are going to need the following two things, like those are two primary ingredients of this stack. And those are the technology and the platform. So you need the technology that would enable you to run sophisticated AI/ML workloads with high performance, and you need a platform where you would be able to actually run those workloads. Now, if you look at that from the vendor perspective, NVIDIA has obviously been a leader on the AI/ML market for a while, providing highly performant GPU cards and enabling them to be partitioned and allocated on demand to workloads running on top of cloud infrastructure. While on the platform side, Ubuntu has long been the most popular Linux distribution across developers, and now, these days, it is also more and more often endorsed by senior executives and managers as well. So NVIDIA provides you with the technology that enables you to maximize performance of your workloads, while Canonical provides you with the platform where all of those hardware and software components can be smoothly integrated. As a result, you can implement your own infrastructure for data science purposes with NVIDIA vGPU technology turned on, from bare metal bottom up, including OpenStack, Kubernetes, Kubeflow, and many other services, all natively available on a single platform. As a result, Canonical has been recently working closely with NVIDIA to deliver the best-in-class user experience for data scientists who are willing to use NVIDIA vGPU technology on top of an Ubuntu-based infrastructure. As a result of this work, we have formed a formal partnership with NVIDIA, including joint engineering efforts and joint commercial offering. So first of all, together we deliver tested and validated drivers for the NVIDIA vGPU software on Ubuntu KVM hypervisor. Since the majority of OpenStack deployments on Ubuntu use KVM as a hypervisor, this is the most natural choice. And then, in addition to those drivers, we ensure smooth integration of the NVIDIA vGPU technology with the Canonical OpenStack, including full automation of both the initial deployment as well as day 2 operations. And finally, we offer joint commercial support for enterprise customers who are willing to run an Ubuntu-based infrastructure with NVIDIA vGPU. This means that whoever is interested in expanding the benefits of NVIDIA vGPU on Canonical OpenStack can now receive support from Canonical and NVIDIA under the Ubuntu Advantage for Infrastructure Support subscription. And now, on that note, I'm going to hand it over to Judy, who will talk a little bit more about the NVIDIA vGPU technology and the benefits that it brings to data scientists. Judy, the floor is yours.
Thanks, Titus. Hello, everyone. It's great to be here today. I'm going to take some time to talk about NVIDIA Virtual GPU technology. NVIDIA powers the GPU Accelerated Data Center with NVIDIA Virtual GPU technology, which allows IT to deliver rich virtual experiences across their user base, from graphics-rich applications to AI and compute workloads. I'd like to spend some time talking about the technology, how different an NVIDIA-enabled VDI environment is over a traditional CPU-only environment. On the left shows a traditional virtualization environment, powered only by a CPU. The virtualization layer is enabled by the software installed on the server. The hypervisor abstracts the underlying hardware, making it accessible to multiple virtual desktops or guest VMs running on a virtualized host. The CPU processes all the compute and graphics workloads. On the right is the NVIDIA Virtual GPU-enabled VDI environment. On the server, an NVIDIA GPU is installed. In addition, NVIDIA Virtual GPU software is installed at the virtualization layer, along with the hypervisor and VDI broker. The NVIDIA Virtual GPU software creates virtual GPUs or vGPUs, enabling multiple VMs to share the physical GPU installed on the server. Or multiple GPUs can be aggregated and shared by a VM to power the most demanding workloads. The NVIDIA Virtual GPU software also includes a driver for every VM, which enables every virtual machine to get the benefits of a GPU, just like a physical desktop has. Because work that was typically done by the CPU has been offloaded to the GPU, the user has a much better experience and more users can be supported. With NVIDIA vGPU software, IT can deliver virtual workstations with performance that is indistinguishable from a physical PC, even when running the most compute-intensive professional applications. Performance studies have also shown that the overhead for a variety of accelerated compute-only GPU workloads is minimal compared with bare metal. Our integrations with Canonical provide IT a complete lifecycle approach to operational management, from infrastructure right-sizing to proactive management and issue remediation. These integrations also allow IT to use the same familiar management tools for deep insights into GPU usage. NVIDIA vGPU supports live migration of accelerated workloads without interruptions to end users. This allows for business continuity and workload balancing. The flexibility to allocate GPU resources mean that IT can better utilize the resources in their data center. Workloads don't have to run in infrastructure silos. They can be placed wherever compute resources have available cycles to run them. Lastly, since virtualization enables all data to remain securely in the data center, the solution helps to ensure infrastructure and data security. Our NVIDIA Virtual GPU software portfolio consists of the following products: NVIDIA Virtual PC and Virtual Apps software for the knowledge and business workers, and NVIDIA RTX Virtual Workstations for creative and technical professionals such as engineers, architects, and designers. But to address the need for powering compute workloads such as artificial intelligence, deep learning, and data science in a virtual machine, we have our NVIDIA Virtual Compute Server, which enables customers to run these workloads in a virtualized environment and benefit from the features and functionality that comes with NVIDIA Virtual GPU technology. NVIDIA Virtual Compute Server enables virtual GPU technology across the entire NVIDIA platform, addressing the virtualized data center running machine learning, deep learning, HPC, and data science applications that are used across all industries. NVIDIA Virtual Compute Server is supported on a variety of NVIDIA GPUs and OEM servers. The Virtual Compute Server software enables the ability to do accelerated, compute-intensive workloads on the Ampere architecture with third-generation Tensor Core GPUs. Multi-instance GPUs, or MIG, is a feature that was introduced and only available on A100 GPUs. MIG provides quality of service for workloads with spatial partitioning of the A100 GPU. vGPU provides workload isolation across multiple users in non-MIG mode, enabled with temporal partition of any data center GPU, not just limited to A100. By coupling VCS with MIG, various size virtual machine profiles can be enabled by configured MIG instance sizes. In addition, when running VMs on the MIGs, different versions of Linux can be run on the same GPU. We also have GPU Direct and GPU Operator. Improved data transfer performance with remote direct memory access. Support for the GPU Operator with vGPU enables the ability to easily deploy NGC containers and scripts in VMs. Now let's take a look at the benefits of NVIDIA Virtual Compute Server. The table shown here gives a side-by-side comparison of running compute workloads with NVIDIA vGPU versus bare metal on the same physical GPU. For the best and maximum performance, running workloads in bare metal provides the best solution. However, in a virtualized environment, vGPU provides additional benefits integrated with the hypervisor, such as management and monitoring, multi-tenancy, and live migration, while maintaining performance that is close to bare metal. And now at this time, I'd like to hand it over to Titus, who will go over NVIDIA GPU on Charmed OpenStack.
Thank you very much, Judy. I really feel like I learned a lot. Let's now dive into the next section of this webinar and let me explain what are the benefits of running NVIDIA vGPU software on top of Canonical OpenStack. So if you think about various potential implementation challenges when building data science stack, there are many things that may turn out to be a challenge. First of all, implementing a known infrastructure entails significant investments that have to be made upfront. You have to purchase the hardware, you have to pay for infrastructure delivery, you have to train your personnel, etc. All of that makes it relatively expensive. High entry barriers are another challenge. Let's be honest with ourselves. Not everyone is an expert in Linux, OpenStack, Kubernetes, or Kubeflow, especially when your primary area of expertise is data science. Another typical challenge is lack of resources or facilities. This is especially true for small startups or organizations which historically used to host their business applications in public clouds. These types of businesses usually do not have a data center and dedicated operations team that could handle own infrastructure deployment and its post-deployment operations. And last but not least, multiple vendors. No one has a capacity and wants to deal with multiple vendors. Having a single vendor who can bridge you with other vendors when needed is definitely a preference. The solution to all of the aforementioned challenges is Canonical's open infrastructure stack. This Ubuntu-based stack uses open source technologies everywhere, from bare metal app to applications. It uses MAS, or Metal as a Service, for bare metal provisioning purposes. It uses OpenStack for your own infrastructure as a service cloud platform implementation. It uses Kubernetes for containers coordination, and Juju as an operator lifecycle manager for various types of applications running on top of OpenStack or Kubernetes. The combination of those four technologies enables organizations to build fully open infrastructure that is available at low cost, that can be used with minimal knowledge and experience, and that can be managed remotely in case there are no resources or facilities on site to handle the ongoing operations. Canonical's open infrastructure stack combines the best of open source on one platform. The presented technologies, Ubuntu, Mass, OpenStack, Kubernetes, and Juju, represent the best of breed set in the open source world these days. And there are obviously many other technologies that are part of this stack, such as QEMU, libvirt, containerd, OVN, Ceph, etc., that are not presented here. Moreover, for the most popular open source applications running on top of this open infrastructure stack, Canonical provides LTS OCI images with 5-year security commitment. This includes various data science tools too. In order to streamline the deployment of such tools and automate their day-to-day operations, Charmed operators are available for a number of open source applications. And last but not least, all of that is available under transparent subscription model. An optional paid subscription, Ubuntu Advantage, provides an access to 24/7 phone and ticket support, on-demand bug fixing, and up to 10 years of security updates. Now, if you think about that, the presented Canonical's open infrastructure stack can be extended with various infrastructure and application components to make it suitable for the data science use case. So first of all, it can be extended with NVIDIA GPUs and the NVIDIA vGPU technology, since starting from OpenStack Charms 2204 release, NVIDIA vGPU software is fully supported in Canonical OpenStack. So system administrators can use Charmed operators to automate the configuration of hypervisors or compute nodes with NVIDIA GPUs attached, and then users can provision cloud instances with vGPU or virtual GPU devices created. And later they can use CUDA to expose those devices up to containers running on top of Canonical Kubernetes that runs on top of Canonical OpenStack. And as a result, any application running on top of Canonical Kubernetes can benefit from highly performant GPU resources, as those can be partitioned across various containers using the NVIDIA vGPU technology. An example of such an application running on top of Canonical Kubernetes is Kubeflow. Kubeflow is an open source machine learning toolkit that translates steps in your data science workflow into Kubernetes jobs, providing the cloud-native interface for your ML libraries, frameworks, pipelines, and notebooks. Canonical provides LTS OCI images as well as Charmed operators for Kubeflow deployments on top of Canonical Kubernetes. Let's now have a look at how Canonical's open infrastructure stack helps to lower high cost associated with building and maintaining an own infrastructure. The diagram on this slide represents a typical IT budget required for cloud infrastructure maintenance. It consists of 4 primary pillars: hardware and facilities, software licenses and services, internal operations and maintenance, and R&D and change. While the R&D and change spendings have a positive impact on the organization, like they help the organization to innovate and grow, the other 3 represent raw cost. Canonical's mission with open infrastructure stack is to decrease the total cost of ownership associated with cloud infrastructure maintenance, leaving much more space for innovation, which at the end of the day helps our customers to be more competitive on the market. And we decrease the TCO of cloud infrastructure maintenance in 3 ways. We provide an optimal architecture for cloud infrastructure implementation. We offer our services at a better price compared to the competition, and we leverage so-called smart operations with total bottom-up automation. Speaking about automation, let's move to the next slide. If you recall from the previous slides about Canonical's open infrastructure stack, you've seen 2 technologies there. You've seen Mass and you've seen Juju. The role of Mass is to automate everything related to bare metal. Mass basically turns a data center into a bare metal cloud and enables on-demand provisioning of physical machines, including operating system installation and customization. In turn, the role of Juju is to automate everything related to applications running on top of bare metal. Juju is an operator lifecycle manager that uses Charmed operators, which contain all the necessary logic required to install, configure, and integrate various components, enabling building complex application topologies. Thanks to Charmed operators, the initial deployment of application ecosystems such as OpenStack, Kubernetes, or Kubeflow, as well as their day 2 operations such as scale out or upgrade, become fully automated. This effectively lowers entry barriers and makes Canonical's open infrastructure stack for data science something that even less skilled personnel can use with no friction. Now, in case someone doesn't really have resources or facilities to build an on-prem infrastructure, Canonical provides fully managed services for OpenStack, Kubernetes, and the most popular open source applications, where the entire infrastructure is built and managed by Canonical cloud experts. This includes 24/7 monitoring and alerting, incident and problem resolution, typical daily operations such as backups, periodic upgrades, etc. All of that helps organizations to enter the data science space faster. They can quickly start with the fully managed infrastructure and progressively move to the self-operated mode as they learn required skills and gain necessary experience to operate it on their own. And finally, by choosing Ubuntu, organizations no longer need to deal with multiple vendors. This results from the Canonical NVIDIA partnership that we talked about earlier in this webinar. Since Canonical and NVIDIA provide now joint commercial support for the NVIDIA vGPU software on Canonical OpenStack, users can stay assured that any potential issues they are going to face will be taken care of by Canonical and handled between Canonical and NVIDIA, even escalation is required. So that's pretty much everything on my side. I'm going to hand it over to Dave now. However, before I do it, let me remind you that you can raise your questions through the question box at any time. You don't necessarily have to wait until the Q&A part. We've already got a bunch of questions, so if you want to make sure that we'll be able to prioritize yours, please do not hesitate to raise them now. And on that note, Dave, over to you.
Hi, I'm Dave Montana, VP of Sales in Americas at Canonical, and I'm going to use a couple of minutes to talk to you about some of the really cool use cases we've got going on with NVIDIA. First off, we've got energy. Traditional business didn't really get into GPU in any big way until maybe the last 10 years. What we've been able to do now using Linux capabilities with Canonical and NVIDIA is to create some incredible capacity to process more data in a much faster time. This allows oil and gas companies to decrease time to oil, and we get results much faster. It's a much greater opportunity to do things like multiple realization and solve much more complex mathematical algorithms. Alongside that, we have some really, really cool use cases in automotive. One of the more interesting that I found growing up watching IKEA use the little machine to open and shut the drawers to see how many times it would be until it failed. That whole process has been applied to automotive. There was a latch with a major automotive manufacturer that they determined wasn't lasting long, and that might have been due to the manufacturing process and how it was fitted. Using some deep learning and NVIDIA's specific GPU capabilities, they were able to actually augment the cameras and look at how the latches were being fitted, look at what was happening over time, and actually fully change how they installed that latch in the manufacturing process, resulting in a much better outcome. By using the GPU as well, they took what they were trying to do with CPU and made it approximately 10 times faster, which is absolutely fantastic. Last use case that we can kind of look at in detail is healthcare. Using the AI ML technologies that we have today, giving data science access to new tools, we can do much more complex investigations into things like cancer research and genomics. We can investigate them much easier than ever before, allow data scientists to create their own models, and we can do much better predictive diagnosis and lessen the load to the humans that are actually doing the work, touching the patients. So overall, we have a number of different areas that we can look at. Healthcare, manufacturing, we can do a lot of things in finance, seismic processing that have been massively improved by NVIDIA's capability to deliver data science and the combination of combining that with Ubuntu. fantastic operations. Would love to speak to people more about this. Open in the Q&A. Love to answer any questions you have. Over to James with a demo of Charmed OpenStack.
Thanks, David. We'll now compare the performance of a TensorFlow machine learning workload on GPU and standard CPUs, leveraging the vGPU deployment capabilities of Charmed OpenStack. To start with, let's take a look at the Charmed OpenStack deployment. In addition to 3 standard OpenStack hypervisors, I've also deployed a 4th hypervisor, Node Sparky, which is equipped with an NVIDIA Tesla V100 GPU, which is vGPU capable. Using the Nova Compute NVIDIA GPU operator, we've installed the required NVIDIA drivers and configured OpenStack to use a mediated device type, which basically divides the GPU into 2 allocatable vGPUs for use in cloud instances. This is all deployed on Ubuntu 20.04 LTS with OpenStack Xena. I have created 2 Ubuntu 20.04 LTS instances on the Charmed OpenStack cloud. Each has a CPU and memory allocation of 8 cores and 16 GB of RAM. One of the instances also has a vGPU slice of the Tesla V100 allocated to it. You can see this in the console on the left-hand side of my screen. To demonstrate the performance of a machine learning workload, I've picked a TensorFlow neural network-based digit classifier trained using the CIFAR10 dataset. This dataset consists of 50,000 training images and 10,000 test images spread across 10 classes. The benchmark executes 5 epochs against the training data, assessing the accuracy of the neural network model during each epoch using the test images provided by the dataset. This benchmark can be run on both GPU, making use of TensorFlow's CUDA integration, and on a standard CPU. Let's compare the performance of the benchmark on these 2 types of processor. Okay, let's kick off the 2 benchmarks. Each benchmark will display a summary of the neural network model it is configured with and then execute the 5 training epochs. As you can see, the GPU-based benchmark is significantly faster, with each epoch completing in around 10 seconds, compared to well over a minute for each epoch on the CPU-based benchmark. We can also confirm the use of the GPU by taking a look at the general load on the 2 benchmark instances. The CPU-based benchmark is fully consuming all 8 cores, whereas the GPU-based benchmark is using the vGPU for all of the hard work. As you can see, the GPU accelerated benchmark is significantly faster than using just CPUs. For this specific workload, it's around 9 times faster using the vGPU. We'll not wait around for the CPU benchmark to complete. I'll now hand you back to Titus.
Thank you, James, for an amazing demo. Moving to the end of this webinar, let's briefly recap what we have learned. So, NVIDIA vGPU software enables partitioning of highly performant GPU resources and allocating them on demand to VMs running on top of various hypervisors. One of those hypervisors is Ubuntu KVM, for which Canonical and NVIDIA provide jointly tested and validated drivers. Since the majority of data scientists run their workloads on top of cloud infrastructure these days, Canonical makes sure so that the NVIDIA vGPU technology is natively available in Canonical OpenStack and can be consumed by cloud instances or Kubernetes clusters running on top of it. Using Canonical OpenStack helps to bypass typical implementation challenges, including high infrastructure costs, high entry barriers, lack of resources or facilities, and dealing with multiple vendors. This comes from its price-performance optimized architecture, total bottom-up automation, Canonical's fully managed services, and joint commercial support provided by Canonical and NVIDIA. And that's pretty much all for today. We would like to thank you very much for your attention. The content of this webinar will be available on demand once it finishes, so feel free to share it with your colleagues if you found it useful. In case you would like to learn more about NVIDIA vGPU, we would like to invite you to visit the NVIDIA website at nvidia.com. And similarly, if you would like to learn more about Canonical OpenStack, we would like to invite you to visit our website at ubuntu.com/openstack. You can also use the contact form from the webinar attachment to get in touch with Canonical Cloud experts. There is also a variety of other attachments that you might find useful, so feel free to browse through them. Don't forget to rate this webinar. We really appreciate your presence here. And now we will be more than happy to answer any questions that you may have. Let's have a look at the inbox.